The atomic bomb stands as a singular invention in human history, a weapon unlike any other conceived before or since. Its very existence fundamentally altered the trajectory of nations, warfare, and global politics. This device, born from the deepest scientific inquiry and forged in the crucible of total war, unleashed a destructive power previously unimaginable. The story of the atomic bomb is not merely one of technological achievement. It is a complex narrative encompassing its clandestine creation, its devastating impact on human lives and cities, and the enduring shadow it has cast over the modern world. Understanding this history is crucial for comprehending the geopolitical landscape we inhabit today. At the heart of the atomic bomb's power lies the atom itself, the fundamental building block of all matter in the universe. For centuries, it was considered indivisible, but early 20th century physics revealed its intricate internal structure. The atom's core, known as the nucleus, contains protons and neutrons, held together by forces of immense strength. These subatomic particles are bound by what is known as the strong nuclear force, the most powerful of the four fundamental forces of nature. Unlocking this force by manipulating the nucleus promised access to unprecedented energy. The key to this unlocking was the process of nuclear fission. Nuclear fission is the process by which an atom's nucleus is split into two or more smaller nuclei. This splitting is not a gentle separation. It is a violent event that releases an extraordinary amount of energy. This energy release is far greater than any chemical reaction, such as burning fossil fuels or conventional explosives. The principle behind this energy release is Einstein's famous equation E=mc², which demonstrates that mass and energy are interchangeable. When a heavy nucleus undergoes fission, a small amount of its mass is converted directly into energy. This conversion accounts for the tremendous power observed. The atomic bomb harnesses this energy through a controlled yet rapidly escalating chain reaction. This concept is central to understanding how such immense power is generated from a relatively small amount of material. It is the mechanism that transforms a scientific curiosity into a weapon of mass destruction. The chain reaction begins when a neutron strikes the nucleus of a fissile material. The most commonly used fissile materials are specific isotopes of uranium, primarily uranium-235, and a synthetic element, plutonium-239. These isotopes are uniquely susceptible to fission when struck by a neutron. Upon impact, the nucleus of the fissile atom splits, releasing not only a burst of energy, but also additional neutrons. These newly released neutrons then go on to strike other nearby fissile nuclei, causing them to split in turn. This process creates a cascade effect, multiplying the fissions exponentially. If enough fissile material is present and configured correctly, this process rapidly escalates into a self-sustaining and incredibly fast chain reaction. Within fractions of a second, billions upon billions of atoms undergo fission, releasing an explosive amount of energy. This uncontrolled rapid chain reaction is the essence of an atomic bomb. The impetus for developing such a weapon was the outbreak of the Second World War and the terrifying prospect of Nazi Germany acquiring it first. Reports from leading scientists, including Albert Einstein, warned President Franklin D. Roosevelt of the potential for a German atomic bomb. This fear ignited a desperate top-secret race against time. In 1942, the United States launched what would become known as the Manhattan Project. This monumental undertaking was an unprecedented collaboration between scientific genius, industrial might, and military organization. Its sole purpose was to develop an atomic weapon before the Axis powers could. The project brought together an extraordinary assembly of brilliant minds from across the globe. Key figures included J. Robert Oppenheimer, the theoretical physicist who directed the Los Alamos Laboratory, and Enrico Fermi, who achieved the first self-sustaining nuclear chain reaction. Their collective intellect was focused on a single daunting goal. Los Alamos, New Mexico, became the clandestine epicenter of this scientific and engineering effort. Built in secrecy on a remote mesa, it was where the theoretical physics was translated into practical weapon design. Thousands of scientists, engineers, and technicians worked in isolation, their mission shrouded in absolute secrecy. The project involved incredibly complex and resource-intensive processes. One major challenge was the separation of uranium-235 from the more common, non-fissile uranium-238. Another was the creation of plutonium-239 in nuclear reactors, a material that does not occur naturally in significant quantities. These tasks required entirely new industrial infrastructure. Throughout its duration, the Manhattan Project maintained an almost impenetrable veil of secrecy. The stakes were immeasurably high, with the outcome of the war and the future of global power hanging in the balance. The success or failure of this endeavor would reshape the world. The culmination of years of intense secret labor arrived on July 16, 1945. In the desolate Jornada del Muerto desert of New Mexico, the world witnessed the first detonation of a nuclear weapon. This event, codenamed Trinity, was a pivotal moment in human history, marking the true dawn of the atomic age. The device, a plutonium implosion bomb nicknamed Gadget, was hoisted atop a 100-foot steel tower. Scientists and military personnel, many of whom had dedicated years to its creation, watched from bunkers miles away, gripped by a mixture of anticipation and profound apprehension. The moment of truth had arrived. At precisely 5:29:45 a.m. Mountain War Time, the desert was consumed by an unearthly, blinding flash of light. It was brighter than 1,000 suns, illuminating the pre-dawn sky with an intensity that seared the retinas of observers, even through protective lenses. The light was followed by a colossal, rapidly expanding fireball. Moments later, a towering mushroom cloud began to ascend into the atmosphere, reaching heights of over 40,000 feet. This iconic, terrifying symbol of nuclear power was born in that instant. The ground shook violently, and a deafening roar echoed across the desert, a sound that many described as the end of the world. The explosion's power was estimated to be equivalent to approximately 20 kilotons of TNT. This single device unleashed more destructive force than all the bombs dropped by the Allies on Germany in 1943. The sheer scale of the energy released was beyond anything humanity had ever engineered. The immediate vicinity of the blast was utterly annihilated. The steel tower on which the bomb rested was vaporized, leaving no trace. The intense heat and pressure carved a crater of fused desert sand, later dubbed Trinitite, into the earth, a permanent scar on the landscape. Scientists, including Oppenheimer, observed the test with a mixture of awe and dread. They meticulously recorded data, confirming the devastating power they had unleashed. The success of Trinity meant that the atomic bomb was no longer a theoretical possibility, but a terrifying reality, ready for deployment. Weeks after the successful Trinity test, the atomic bomb was deployed in war. On August 6, 1945, the B-29 bomber Enola Gay dropped a uranium-based bomb, nicknamed Little Boy, on the Japanese city of Hiroshima. The decision to use this weapon was made in the hope of bringing a swift end to the brutal conflict of World War II. At 8:15 a.m. local time, the bomb detonated approximately 1,900 feet above the city. The blast instantly obliterated the city center, turning buildings into dust and vaporizing thousands of people. The destructive force was absolute, leaving behind a landscape of unimaginable devastation. Just 3 days later, on August 9, 1945, a second atomic bomb, Fat Man, a plutonium-based device, was dropped on Nagasaki. This city, a major port and industrial center, suffered a similar fate, though its hilly terrain somewhat contained the immediate blast effects compared to Hiroshima's flat expanse. The immediate destruction in both cities was catastrophic. Tens of thousands of lives were lost instantly, vaporized by the intense heat, crushed by collapsing buildings, or incinerated by the firestorms that raged for hours. The scale of human suffering was unprecedented, a stark demonstration of the bomb's horrific power. Beyond the immediate devastation, the atomic bombs inflicted long-term effects that continue to haunt survivors and their descendants. radiation poisoning caused agonizing deaths in the weeks and months following the attacks, leading to a slow, painful decline for many. Survivors faced increased risks of cancers, birth defects, and other chronic illnesses. The genetic damage passed down through generations remains a subject of ongoing study and concern.